On today's exciting episode of Geometry, two-dimensional figures. In two dimensions, did not a moving line produce a square with four terminal points? That's from Edwin A. Abbott, his book Flatland, A Romance of Many Dimensions. Okay, polygons. So a polygon is a closed figure formed by a finite number of coplanar segments called sides, such that the sides that have a common endpoint are non-collinear, and each side intersects exactly two other sides, but only at their endpoints. So the vertex of each angle is a vertex of the polygon. Okay, so a polygon is named by the letters of the vertices written in order of consecutive vertices. So what does that mean? Well, in this case, we have polygon GHJKLM, right? So we're starting here and we are moving our way around the polygon, and every time we get to a new vertex, that becomes part of the name until we get back to where we started. Now, that doesn't have to be what the name is. It can be any starting point. So I could have started at L and gone L, K, J, H, G, M, J. And that would be the name of this polygon. It'd still be correct. Okay, so polygons such as this have quite a few names that it can have. Okay, here we see that we have this side, right? That is this segment. Okay, the vertex J, that's right there. That's the point of that the point that the two sides meet. Okay, so here we have some figures, and on the left, those are all polygons. Okay, on the right, I have a number of figures, but they're not all polygons. Now this one here, this first one, let's take a look at, and we can see that there is a triangle here, and I have another triangle right here. Those two are separately polygons, okay? But this whole thing here, this whole figure is not a polygon, okay? This is curved. This one's got a curve to it, so nope. Anything with a curve is not a polygon, right? So this one here, this one here, this one here. This one is open right there, and so that's not a polygon. Again, this one is similar. The last one here is similar in that if I just went with this figure right here, right, this one I'm coloring in purple here, that's a polygon, okay? But the whole thing, this whole thing is not, okay, because of this little extension right here. Okay, so polygons can be what's called concave or convex. So basically what this entails is that we have a polygon here, and if I take any side and extend it, it doesn't cross into the interior. Okay. If we look here at these lines right here, so this line right here crosses the interior. This line right here crosses into the interior, right? So this has got interior points right here. Where's my... Here and here. right? So that's got interior points there. That's why it's not a polygon. Another thing I always tell students, here's a way of looking at this. That's been caved in, right? It looks like that side is caved in, right? So that would be called concave, right? Because it looks like it got kicked in, all right? So we might say that because it's got this dent, right? It's not just right here, right? You have this area here that's kind of been kicked in, caved in, concave, right? It's another way of looking at that. All right, so we classify a polygon by its number of sides. So on this chart here, and we can look at this, we have everything from triangle, right? Tri, 3, quadrilateral, quad is 4, penta, 5, pentagon, hexagon, 6, heptagon, 7, octagon, 8, nonagon, 9, decagon, 10. Those are Greek numbers. Hendecagon is 11, dodecagon, 12. If we have more than 12 sides, we take the number, right? So if I have a, let's see, a 37-sided polygon, we would just call that a 37gon. Okay? So anything over 12, we don't really bother with anymore. Okay, equilateral polygon. All the sides are congruent, right? All the sides are congruent. Equilateral, right? Lateral is like line, right? So equal lines, all sides congruent. Equiangular, all the angles are congruent. A regular polygon is a polygon that is both equilateral and equiangular. It's got to be both, okay? Equilateral and equiangular. Okay, so a couple of definitions now that we're going to talk about. And the first one is perimeter. Perimeter. That is the sum of the lengths of the sides. All right? So if we walk along the perimeter of a polygon, or we measure along each side, we just keep adding to the total. All right? The circumference of a circle is the distance around a circle. Now, when we get to working and solving for circumference, you're going to see this value, and that's known as pi, okay? And pi is going to always be involved with anything with circles. So once we get that idea, keep that in mind, all right? So circumference, all right, is the distance around a circle, okay? The area of a figure is the number of square units needed to cover a surface, right? So if you think about carpet, right? That's they cover a floor with carpet. Okay, we want to know the area. All right, that's what they call the area, the number of square feet, let's say, or square yards. All right, square meters. If we're doing metric. Okay, so this page you need to try to memorize as much as possible. But what we will do, we'll have something that you can use, and so we don't have to memorize all of these, okay? But if you'll see here, if you should notice, right, that the letter P is perimeter, B is base, H is height, A is area, length, width, circumference, radius, and diameter. So all of these formulas you're going to have to be able to use. But we will have aids in our classroom that you'll be able to take a quick look at and figure out those formulas. Time for some example problems. All right, find the perimeter or circumference and area. So this is a rectangle, and because it's a rectangle, we're going to take a couple of things here. So there's a couple of different ways that we can do this, and we can say that this is equal to the length and this is equal to the width, right? I don't like the way my W came out looking there. Width, okay. Now, the thing about rectangles is this one here would also be 2.1, and this one here would be 3.2. So there's two ways we can do this. If we're going to find the perimeter, we can just take the perimeter and say 3.2 plus 2.1 plus 3.2 plus 2.1. And we can add those up, and it doesn't hurt to use your handy dandy calculator, right, at this point. So we get 10.6, right, as our perimeter, 10.6 centimeters. Now the other way you could have done this, if you might have said that the perimeter, I can add the length times the width, or plus the width, so 3.2 plus 2.1, and then double it, because there's two of them, right? And basically you'd end up doing that the perimeter is equal to 5.3 times 2, and so our perimeter is going to be equal to 10.6. Now the area is always equal to the length times the width. So in this case we'd have area is equal to the length, which we would say is 3.2, times the width, which is 2.1. So I take my calculator and I say 3.2 times 2.1, and I've got 6.72. So the area is equal to 6.72 centimeters squared. Get in the habit of looking at the units because that's important. Okay. Okay, now we want to find, this is going to be a circle, right? This is not going to be, it is a circle. And so we're going to find the circumference of the circle and the area. Okay, so our formula for circumference is, in this case, the circumference is either equal to pi times the diameter. The diameter would run all the way across here, right? Or else we could just say, or this is equal to 2 times pi times the radius. Okay. Now, when we're given these problems, if the questions are asking us to solve for circumference to the nearest hundredth, okay, or we can say just in terms of pi. So in this case, let's solve for pi in terms of pi. So the circumference would be equal to 2 times pi times the radius, which is 3. So the circumference is equal to 6 pi. Now let's assume that the circumference, I ask you to solve for the circumference to the nearest hundredth. Well, you can just take this now and multiply that with your calculator. But the difference is 6 pi would be an exact measurement. And we would say 6 times pi on our calculator, and we get 18.849555592, blah, 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 because pi goes on forever. So this would be approximately 18.85. Okay? Now, area of a circle is equal to pi times the radius squared. So the area of this would basically be equal to pi times 3 squared. Well, 3 squared is equal to 9, so this is equal to 9 pi. Now, if I want to solve to the nearest hundredth, I would say area is approximately, and I would say 9 times pi. And that comes out to 28.274333, so I'm just going to round it to 28.27. And this is all, this one's just inches. This is inches squared. Right, if we're being correct with our units. All right, at this time, you guys go ahead and find the perimeter of this and the area of this figure, and I'll be back with you in a short minute. Okay, so here we go. Let's solve for the perimeter. Again, our perimeter is equal to, and we'll do this, I'm just going to double it, right? 2 times the length plus the width, right? We can do this one. So I just plug in 2 times the length, I'll say is 6 plus 5.5. So the perimeter is equal to 2 times 11.5. So my perimeter is equal to 23, right? Now, my area, again, is real simple, length times width. So my area is just going to be 6 times 5.5. So my area is, and let's take the handy dandy calculator and plug it in. And I've got the area is 33 square feet, right? The perimeter is just feet. All right, you go ahead and find it first in pi, find the perimeter, find the circumference in terms of pi, and then go ahead and find the circumference to the nearest hundredth, and then again with the area in terms of pi, and then find it to the nearest hundredth. Go ahead and work on that right now. Okay, we're back. All right, so here we go. So our first thing we're going to find is circumference. So this is a diameter, right? So keep that in mind. This length is all the way across 6.2. So my circumference is 6.2 pi times the diameter, right? This is equal to pi times the diameter. Diameter is 6.2, so this is just going to be 6.2 pi in terms of pi. Now we're going to solve for it in terms of to the nearest hundredth, right? We've already got pi in terms of pi. So 6.2, and I put in pi. Oops. And that comes out to 19.47787. So we're going to say this is 19.48 centimeters. Okay, now that we know, though, that this is a diameter, we need to find this distance right here. So we divide it in half because it's each radius, the radii have to be equal. So 6.2 divided by 2 is equal to 3.1. So now area is equal to pi times the radius squared. So my area is equal to pi times 3.1 squared. So I could take my calculator and just 3.1 and square it, and I get 9.61. So the area is 9.61 square centimeters. Oops, nope, it's not. It's not. Why? I forgot pi. Pi centimeters squared. Now we're good. All right, so now let's do the approximation. So 9.61 times pi, and I get 30.1907054. So this is approximately 30.19 square centimeters. Okay. Okay, well now we got a triangle. So let's use our thinking caps. We can look at our guided notes and use those formulas, and let's go ahead and solve for the perimeter and the area of a triangle. You go ahead and do that. I'll be right back with you in a moment. All right, I'm back. Okay, so let's go ahead and find the perimeter. Okay, so the perimeter is going to be equal to 9.5 plus 9.5 plus 10.2. So you want to use your calculator again to take those values, add them up, and I've got 29.2. So my perimeter is 29.2 inches. Okay, so my next part of this is my area. The area is equal to 1/2 the base times the height. So what we have to figure out is which one's the base and which one's the height. So the base is always got this right here. Okay, let me go back through this here. This is what makes the base right here, this right there. Where the right angle comes down, and they should draw that in, that's the height, or the base, excuse me. The base is, this is the base. All right, this here is the base value. That makes this one the height. Okay? So, we go ahead and plug in. So, area is equal to 1/2 the base, which is 10.2, times the height, which is 8. So to put this in your calculator, you can put just 0.5 times 10.2 times 8. and you get 40.8. Squared inches. Another little trick you can use would be to cut this value here. The easiest one to cut in half would be 8. 1/2 times, so multiply 1/2 times 8, that's 4, and then multiply that by 10.2 and you get the same answer. Okay, I don't know why that's in there, but let's all have a good laugh with Nelson. And that's it for this chapter of geometry. This was two-dimensional figures.
That's all, folks.